Hello. This podcast is available unedited and ad-free at patreon.com/Hamilton Morris. Each month, I release 3 to 4 new podcasts, and it was Patreon exclusive until recently. Many people contacted me and said they wanted me to figure out a way to make it freely available, and so I decided to accept sponsorship from a few of my friends. One of them is David Rentlin, the founder of a company called Lucy Nicotine. They make nicotine gum, nicotine pouches, nicotine lozenges, some of which are made with synthetic nicotine, which I think is pretty cool. Now, if you don't already use nicotine, I recommend that you don't start. It's habit forming. But if you already do use nicotine products, and especially if you smoke tobacco cigarettes, I can say that this is a cleaner product. And it's also a product that I use personally. If you go to lucy.co and use the code Hamilton, you get 20% off your purchase. Okay, here we go. So I'm really happy to share this interview with Robert Oberlender. He is not a household name like David E. Nichols or Alexander Shulgin or Albert Hofmann. But it's very important to recognize that behind these titans of psychedelic chemistry, there are dozens of other researchers who were toiling away and building the framework around these discoveries. Brilliant chemists, people like Robert Oberlender or David Repke or Peyton Jacobs or Stuart Frescus, and the list goes on and on and on. These are people who themselves synthesized and evaluated dozens of compounds, and it's often their chemistry and their reports that are incorporated into P-call and T-call. This is a typical beginner mistake when you first pick up P-call and T-call. You think, my God, he synthesized and tried all of these drugs himself, and to be sure, he synthesized and tried many, many drugs himself. But many of these syntheses and evaluations are from other people. And that's a good thing. When you're evaluating a novel compound, you want as many data points as possible, and you want to test it in as diverse a population as possible. If every report had come from Shulgin, that would actually be less valuable. It's good that these reports are collected from different members of his research group, sometimes from people that he corresponded with, and sometimes from people like Robert Oberlender. I remember that the first time I met Robert Oberlender, it was in 2017 at a MAPS conference. And a chemist that I knew said, Robert Oberlender's here. You've got to meet him. And I said, I don't know if I'm familiar. Who is that? He said, oh, you don't know who Robert Oberlender is? He's a legend. And the name was sort of familiar, but he's just one of these names. You see a scientific publication, a paper authored by David E. Nichols, Robert Oberlender, and there's no story behind it. You don't really know who this guy is. And so he brought me up to a hotel room and I started talking. Robert Oberlender is this jolly, calm, kind, wonderful person. We had a great conversation, and I've talked to him periodically since, and he's always been so helpful and wonderful. And his story, I think, is really a fascinating one. I mean, he worked on all sorts of different scientific problems and drug discrimination and structure-activity relationships. And he was doing all of this during a time when most psychedelic historians said that research was over. I mean, these were the dark ages. This was the Reagan administration when clinical research had been shut down, but the chemistry research and the underground self-experimentation very much continued. Some of the things that Robert Oberlender worked on were the synthesis of various butyl derivatives of 2,5-dimethoxyamphetamine, DOBU, that's the N-butyl, the isobutyl, and the sec-butyl. And the sec-butyl is of special interest because of its synthetic difficulty and because it contains a chiral carbon that can be used to investigate the stereochemistry of the extremely important 4 position on phenethylamine molecules. I mean, this is considered, Shulgin called it the magic 4 position, right? This is the most important portion of a psychedelic phenethylamine, and the introduction of a chiral center allows you to study the optimal orientation in the 5-HT2A receptor. So this was actually a really important problem, and the chemistry was extremely difficult. I mean, when you look at the way that he first synthesized the sec-butyl, it's quite weird, very unexpected. I would have thought he would have, done a Friedel-Crafts alkylation or something, but he actually started with 2,5-dimethoxyacetophenone, reacted that with ethyl magnesium bromide in a Grignard reaction. That produced a tertiary alcohol, which he dehydrated with paratoluene sulfonic acid, and then hydrogenated the double bond with palladium on carbon. So quite tricky chemistry to get the racemic 4-sec-butyl. And then he made the amphetamine, which is a mixture of 4 isomers. So there's a lot of cool stereochemistry to probe, but he wasn't able to separate the diastereomers via chromatography. In some instances, you can do that. Diastereomers have different physical properties, LSD being one example, and you can sometimes separate them with chromatography, but this was not one of those cases. So he dedicated a huge amount of time to figuring out how to stereoselectively synthesize the 4-sec-butyl amphetamines. He ended up doing this kind of bizarre chemistry that is detailed in his dissertation that I have attached, but it was very much non-trivial. And that was just one of the things that he was working on. And this whole 4-sec-butyl thing is very interesting to me. And I think it even inspired Shulgin. There's a really cool section in Pikal where Shulgin was attempting to synthesize a compound that he never finished called 2CT17. And that was the thiosec-butyl. Shulgin wanted to introduce enantiopure sec-butyl groups onto a sulfur in the 4 position. And the way he did that, I think, was really clever as well. For anyone listening to this who's taken organic chemistry, you'll be familiar with SN1 and SN2 reactions. And the major stereochemical difference between these two reactions is that in an SN1 reaction, you have racemization of any chiral centers. And in an SN2 reaction, you have inversion. So if you start out with 100% R in an SN1 reaction, you get a 50-50 mixture of R and S in enantiomers. And in an SN2 reaction, if you start out with 100% R, you end up with 100% S. So Shulgin had the idea to start with enantiopure sec-butanol, make a tosylate, which is a great leaving group, react that with the aromatic thiol. And if it went via a pure SN2 route, then you'd end up with the inverted enantiopure isomer of the thiosec-butyl compound. But he never finished these syntheses. Anyway, this is just really cool chemistry. The other thing he was working on was conformationally constrained lysergimides. When you have a really powerful molecule like LSD, and you know that the NN diethylamide substituent is crucial for activity, right? This is something that Hoffman discovered at the very beginning. Dimethyl doesn't do it. Dipropyl doesn't do it. It's pretty much got to be diethyl. There's some things you can do that retain activity, but diethyl is very, very potent compared to most of the other simple dialkyl substituents. Why is that? In order to answer that question, one of the best ways to go about it is to synthesize conformationally constrained derivatives where the diethyl group is bound into a rigid framework, ideally one with chiral carbons, so you can investigate the optimal binding orientation of those groups. When you synthesize a conformationally constrained molecule, you want to modify it as little as possible. Otherwise, you're kind of introducing additional variables into the problem. So the ideal way to do that would be with a 2,3-dimethyl aziridine ring, because then you're still dealing with just 4 carbons, right? You're not introducing any carbon bulk. It's the perfect way to constrain the diethyl groups in LSD. The problem was that it was synthetically impossible. Oberlender couldn't do it. But in his failure, he created an alkyl chloride that I feel must have inspired Nichols in the CLAD that he later spent so much time working on. I mean, this is what I love about chemistry. Even failures can very easily turn into successes. And so you find all these things that superficially look like a problem, but they led to beautiful research. And another instance of this would be Oberlender's overdose on 5-methoxypyrrolidine tryptamine, which I think is one of the most fascinating stories in underground psychedelic scientific research, and one that has never been told publicly before this conversation. I don't want to spoil it, but I think it's an example of how you can look in the scientific literature and you can see, 5-methoxyprolyl-tryptamine. It's a potent psychedelic. But until a human being tries it, you don't really know what it is. And this turned out to be quite an unusual molecule, not a classical psychedelic by any stretch of the imagination. It induces something closer to a dissociative fugue. And I remember reading these reports in Tikal and thinking, for one, these reports are not written by Shulgin. The first one, I believe, is written by Shulgin. I'll read that right now. There's a early report for 0.5 milligrams orally, and this is what is written. This stuff is an absolute poison. Within minutes, I noticed what can only be called ear ringing without any ear ringing. Intense tinnitus with no sound. Most uncomfortable. There were 2 waves of nausea and vomiting of yellow, bilious stuff with thick mucus for saliva. I can't think straight. Muddled. I can't get answers to questions because I simply cannot form the questions. Eyes closed to music gave no images, but the music sounded okay. Recovery was quite rapid, and I was together again in a few hours. Never again. So that report could have come from Shulgin, but there's a later report that most certainly is not by Shulgin, which I found really interesting. So this is a report for 4 milligrams smoked. This was the freebase. I remember the pipe and the inhalation, and with the pouring of a small glass of scotch, I settled down in front of the TV to watch a rerun of Star Trek. That's definitely not Shulgin. He didn't watch TV. That was it. I came to sometime later in the front room of a professional ally of mine who had by chance discovered me walking down the street near his house. I do not recall, nor have I ever been able to regain any memories of the time I was out there. I apparently experienced no physical discomfort from the drug. In fact, I distinctly remember feeling very comfortable when I awoke. Clearly, this compound is some weird-ass shit. Okay, so that's not Shulgin-like language. But Shulgin was aware of what happened to Oberlender, and he wrote in the extensions and commentary, "There is another message of warning. Here one must accept the eloquent argument that for the structuring of an experiment with an unknown and thus undefined new drug, there must be observers present who are both sober and sympathetic. The heroic and macho 'I'll do it my way' can lead to both psychological problems and physical risks. As with scuba diving, always work with a partner." And I think that's an especially interesting analogy because, of course, the great psychedelic researcher Walter Pahnke died scuba diving without a partner, a story I'm sure Shulgin was aware of. So Oberlender worked with Nichols, made these amazing discoveries, and as if that weren't enough, he then invented Vyvanse, which is dextroamphetamine bound to the amino acid lysine, which is one hell of a blockbuster drug. It makes something like $2 billion a year for Takeda. This is a hugely profitable drug. It's made probably tens of billions since its release, and it was discovered by Robert Oberlender. So you have a person who suffered what was at the time a catastrophic accident in the context of his scientific research, and then went on to discover one of the most successful ADHD medications of all time. I could talk about Oberlender's work all day. It's totally fascinating, and I don't want to give too much of this away. Before the conversation begins, I want to apologize for the audio quality. I did my best to try to equalize it, and it was hard. This is a recording of a phone call, and I'm doing my best to try to book studio sessions for future interviews, but sometimes it's logistically not possible at the moment. So I hope you can forgive the audio quality, maybe put on a pair of headphones, listen carefully, because this is somebody who has an amazing story. He's careful about what he says. As with all of these interviews, read between the lines. There's a lot of fascinating things being discussed, and I hope you enjoy it. So thank you so much for agreeing to talk about all this. I I've heard a couple of these stories about your research, but like I said, I was going through your dissertation and I was amazed by the diversity of different areas that you studied while you were at the Nichols lab. And it's really kind of an impressive array of different problems you were addressing and different things you were trying to figure out. But I'm curious, before even getting into that, how you got started in any of this. What was the beginning of your research on psychedelics?
Well, I guess it goes back to my first year in college. I had an opportunity to try psychedelics and became really interested in them. And then I went to pharmacy school at Temple University in Philadelphia. And I had a medchem teacher, Pete Dukas, later became the dean. And he talked about the structure-activity relationships of stimulants. And then he included in his talk several psychedelics. And he was following Nichols and Shulgin, and he presented it to the undergrad pharmacy class. And I thought, what did he just say? And I went up to him after class, and I told him I'd be interested in looking at whatever he had. And he gave me his file. He had about 10 or 15 papers that he had collected over the years. And I thought, wow, this is really, really something. So that was like 1977. And I managed to attend a conference in San Francisco the next year in 1978. Oh, I forgot the title at the time. But it had a lot of ethnopharmacology. And Maria Sabino was a guest there. And Andy Weil was there, and Sasha Shulgin was there. So I got to hear Sasha's Dirty Pictures talk. And I didn't really talk to him at the time, but it was clear that Sasha wasn't accepting graduate students, but Dave Nichols was. So with the encouragement of my professor at Temple, I contacted Dave Nichols and asked him if he was taking graduate students. And he said, sure, he was, and he invited me to come and visit him at Purdue. So I graduated pharmacy school, and I was working for a couple of years, but I fully intended to start Purdue if I'd get accepted at the earliest convenience. And I went to visit Dave in the summer, I think, of 1980. Yeah, it was definitely 1980, because he was really freaked out about Ronald Reagan being elected president. And I thought, oh, there's no way he's going to get elected. Well, things didn't turn out that way. Anyway, I applied and got accepted. They had a rule there that the professors were not allowed to individually recruit graduate students. Instead, each year's graduate students in the department, it was then medicinal chemistry and pharmacology, the pool of students would apply with their first, second, third ranked professors. And then the professors would decide, based on the first semester grades and other things, which graduate students they wanted. And lucky enough, I got selected. And this was in 1981. Started working for Dave in the spring semester of 81, getting my courses done. And then started doing research later that year, a little bit at first, and then more and more until I got my courses done.
I'm going to pause momentarily for an ad. This podcast is also brought to you by the Apollo. The Apollo is a wearable, vibrating bracelet or anklet that appears to be able to modulate your consciousness. And when I first heard about this thing, I was very skeptical. I was at a conference and met a psychiatrist and neuroscientist named David Rabin, and he had built this prototype and let me wear it for a night. During the entire night, I felt very calm and euphoric and good. And I thought, okay, well, maybe this is just placebo. But I also told him that if he ever built more of them, I'd really like to try it again. So he sent me one, and now I've used it for hundreds of hours. It's a very versatile, wearable device that they are selling for stress relief, but you can modulate the frequency of the vibrations to create either a stimulating or calming effect. You can actually sleep wearing it and it seems to help sleep, or you can change the frequency and it has a sort of stimulating effect, which I sometimes use while I'm on a long drive. I've tried a lot of these different non-pharmacological means for alteration of consciousness, like binaural beats and various types of stroboscopic visual stimulation. Usually I'm skeptical of this sort of thing, but this tactile modulation of mood actually does seem to work. The idea being that it delivers a gentle, soothing vibration that conditions your nervous system to recover and rebalance after stress. That's the idea. It's sort of like a vibrating chair or strapping a purring kitten to your leg. If you find a purring kitten calming, then I think you would also find this calming. It's a similar sort of phenomenon. If you're interested in getting one of these devices, you can go to apolloneuro.com to read more about it and use the promo code Hamilton for 10% off. Thank you, Apollo. And when you were first going to pharmacy school, presumably you never thought that you would get involved with psychedelics. I mean, it's a very rare thing to get involved in that world. So what were you thinking you were going to do?
Well, I remember writing to Andrew Weil at the time, and he was recommending ethnobotany, which is a big interest of his. But I wasn't all that interested in botany. I didn't have the background for it. So I didn't anticipate that there'd be any modern medicinal chemists looking at this until I got Keith Ducas's file and found that, yeah, these two guys were hot on the trail and they were doing really interesting stuff. So that became my goal early on to continue. It really fit because Dave was at a pharmacy school. So that background in pharmacy really helped me. And that was the clear way to go.
And what were the other people like in the Nichols lab? For an outsider, someone that doesn't know anything about it, this world of academic psychedelic research seems very mysterious. What kind of person is involved in this world? Who was there? Who was working with David Nichols at that time?
Yeah, that's a good question. All right. Well, typically the medicinal chemistry graduate student, somebody with an undergraduate degree in chemistry and looking to do something that would land them a job in industry. Very few of the people were looking at a career in academic research. I think Dave was an exception. He never had students who were really interested in the societal aspects of psychedelic drug use. But when I got there, there were two students who had started before me working in Dave's group. And the senior student was a guy named David Lloyd, who he was a long-haired hippie, and he had really real knack for making cool tryptamines. And the other one was a guy named Andrew Hoffman. He ended up being my lab partner, and he was a pharmacy student, and he had Nichols in his class in pharmacy school at Purdue. So that was the core of the undergraduates or graduates that were really interested in more than just the academic part or the publications part. And, Dave was just a publication machine. He was filing grant applications left and right, and he had a lot of respect over at the National Institute on Drug Abuse, where he was continuously getting support to test out his theories and develop the structure-activity relationships of the class.
Right. I think there's this narrative that's widely described in the psychedelic community that after the work of Bill Richards was shut down, that psychedelic research completely ended, that it was over. And of course, clinical research on humans had ended in the United States, but there were certainly chemists working. And so during these dark ages, there were people like you and people like David Nichols that were continuously researching this area and doing very important work. So it never actually ended.
Right, you're right. The clinical aspects ended and people had quit trying. But Dave always had, ever since I could remember, it was a dream of his to start a psychedelic institute that would eventually catalyze the return of clinical research. But in the meantime, we had the challenge of adapting an animal model that we could use at least to evaluate our compounds and to be able to publish some sort of in vivo activity. And I was very fortunate in terms of my timing because Dave was wanting to get a new model up that was being practiced by Richard Glennon, the two-lever drug discrimination model, which seemed to be a lot more sensitive and have really good human correlations with like Sasha's data. So that was always the goal, to evaluate the compounds using drug discrimination and then kind of validate those compounds by comparing the potency with material, the evaluations that Sasha had published over the years. So I was lucky I got on the ground floor setting up that drug discrimination apparatus. There was a guy in the pharmacology department, Joe Zabik, who had 30 operant chambers all set up from research that he had done in years past. So with his help, we got those chambers working, and Dave wrote the program for a PC computer that would automatically correlate or document the data, bring in the data, and reward the rats when they pressed 50 presses on the correct lever. And within a matter of months, we had that assay up and running. And we had LSD-trained rats that we use as our model. And we were raring to go. And that was good for me, because whatever other psychedelics were made by other members of the group, we would channel the drugs through the drug discrimination model and compare them with LSD. So that allowed me to work on a number of different projects that I might not have worked on otherwise.
Right. And so for people that are unfamiliar with this sort of work and also unfamiliar with Glennon, could you give just a tiny bit of background on drug discrimination and Glennon and this entire concept?
Sure. It's an operant conditioning model, so it goes back to the Skinner boxes of days of yore. And it's a way for the rat to use the stimulus of the interoceptive cue, they call it, of what the rat experiences when he gets LSD, for example, the training drug. So the rat can clearly distinguish after he got an injection of LSD versus the way he felt his lack of interoceptive cue after an injection of saline. So what the rat is essentially telling us is, are you tripping or do you feel normal? And then much of it depends on the details of the assay and the dosage of the training drug. And Glennon had really worked on this for a few years before we got into it. He was using 5-methoxy-DMT as the training drug. He wasn't using LSD. But he had a couple of years head start on us of publishing data in this area. So he ended up basing our model on work that was being done in the University of South Carolina by James Weil, who was a psychologist working down there. But there were a number of people in psychology and pharmacology who were working on a two-lever drug discrimination assay. So the two levers basically are associated with either training drug or saline. And the idea is you train the rats and keep them trained to press the training drug lever when they got an injection of the drug, and conversely to press the other lever, left or right, after they feel normal from a saline injection. As long as they could perform to criteria in 2 days of training, then we would use the next day as a test day. So we would weed out rats that weren't performing up to speed and only test the rats who were right on in terms of being able to discriminate drug versus saline. So we were off to the races with that.
And how often was that the case, that a rodent couldn't discriminate?
We initially had maybe 10 or 20 rats in the colony. And I would say every training day, we had typically 8, maybe 1 or 2 didn't perform well. We had to screen them out. But initially 10 rats, and then we expanded our week. So we would do a training day on Monday and Tuesday. And for the rats who performed well on those days up to criteria, we would then use Wednesday as a test day, and then cycle it again on Thursday and Friday training days, and do another test day on Saturday. And that went from, say, 1982 or 3 when it first got set up, all the way through to when I left in 1989. We expanded from LSD and included other test drugs. Around the mid 1980s, 1985, we were out on the lead of the empathogen model. So we expanded to testing stimulants. We had dextroamphetamine rats. We were testing MDMA and doing comparisons of the isomers. And then when we found MDDB, the alpha ethyl homolog, which produced the neurotoxicity, we had a set of rats trained on MDDB versus saline. So at the high point of my time there, we had 5 different groups of rats trained on 5 different training drugs that we were running through the experiment twice a week. So we were just accumulating tons of data. I remember clearly it was a talk that I gave at a pharmacology conference. It was the president of the Society of the Stimulus Properties of Drugs, SSPD, would hold a satellite meeting every year. And I presented the overview of why we think entactogens are a separate group in pharmacology and presented all the data from our different rats. And Steve Holtzman was a psychologist from Emory University in Atlanta. He was president of the society at the time. And it was one of the highlights of my career was go to sit back down after I gave my talk. And he looked up and said, "That's a lot of work." I said, "Yeah, thanks." So it was appreciated. It was kind of weird because Dave, being a medicinal chemist, wasn't readily accepted by the pharmacologists or the psychologists. We were kind of on our own.
Right. And this is an interesting model compared to something like just looking at head twitch response. What advantages does drug discrimination have over other ways of assessing drug activity in rodents?
Right, it's much more specific. So with the head twitch, or what was popular at the time, there was a fundus, and Richard Glennon was doing work with the rat fundus model where you sacrifice the rat and dissect the stomach, take a strip of the stomach, and hook it up to these transducers. So when you add a serotonin agonist, the muscle would contract. And one of our early papers was to challenge the adequacy of the rat fundus test in assaying psychedelics. It was non-specific. And the beauty of the drug discrimination assay was that it was very specific. If the drug didn't work exactly like the training drug, the rats would tend to be disrupted. They wouldn't finish 50 presses on either lever. So you can kind of screen out drugs that weren't exactly the same. There was a lot of discrimination when you train a rat to a certain dose, to a certain drug, and then compare that with saline, much more specific. And it correlated better with Sasha's data, which was our measure of relevancy.
Right. Was there competition with Glennon?
Well, Dave and Glennon went back before I started working for him, and I don't think they were good buddies. But yeah, you could say competition.
I've always found Glennon mysterious because he's never at psychedelic conferences. He doesn't seem to be part of the psychedelic community, yet he's one of the most prolific researchers in the area of psychedelics. Yet I don't know anyone other than Dave Nichols that's even spoken with him. Have you met him?
Yeah, I met him. He's a pretty quiet guy. It's hard to get him out of his shell. There was another guy who worked with him who was doing all the drug discrimination stuff. I forgot his name. He was a little bit more friendly. But yeah, without getting too much into personalities, I think Glennon really wasn't the type of guy that you could buddy up with, and certainly never impressed me as someone who had a consuming interest in psychedelics.
Well, I find that so odd to publish dozens, maybe even 100 papers on psychedelics, but not feel a connection to them. It's very interesting to imagine that.
Well, if I may try to explain that, I would gather that Glennon's intrigue with the class and his hard work on developing the studies that he did was more to do with his ability to get grants funded and stay active in research. It was just a sweet spot for him, because he was working out of Richmond at the Virginia Medical School. I forgot what it was called, MCP. Anyway, they had a big pharmacology department, and a lot of the professors there were interested in addiction sciences and research on drugs and abuse. So I guess it was, in addition, it was a way for him to fit in with the focus of the department in general. And it just led to lots of papers and lots of grants. But no, I never got any warm and fuzzy feelings from talking to Glennon. And it was clear that there was some kind of competition going on there with Dave. Dave didn't have a lot of good things to say about him. I think, that they're both well retired now. I'm not sure what Glennon's doing. And I know you've been in touch with Dave, so.
Yeah.
Ancient history. All ancient history now.
Yeah, but I mean, all this stuff, it's not going away. If anything, it may be ancient history, but it's more important than it's ever been. Everyone is combing through all this literature from the 70s and the 80s right now, trying to figure out how it can be commercialized, how it can be used to create the next therapeutic psychedelic. I mean, there's probably more people reading your work now than ever before.
Yeah, and several others have continued to do drug discrimination with psychedelics. I know my biggest hero in the field was a postdoc working with James Appel in South Carolina. That was Catherine Cunningham. She was a good friend. She was a voice of encouragement for a young graduate student just heading out. And there were a couple other people, but I remember the name correctly. In Western Michigan, there's a Brenda Baker who was doing stuff on psychedelics, drug discrimination. And then there's this guy in Arkansas now, Venturoni, I forgot his name, Canturosi. Well, he was doing drug discrimination as well. So it's good to see that the assay is being continued with others. And it would amaze me going from week to week during the projects that we were involved in, how well the data worked out. We were getting these beautiful curves, dose response curves and curves of the number of positives over time. It was just like it was the data god looking positively on us and giving us great data to publish cool papers. So I'm really grateful that we hit on that when we did, developed it the way we did.
And do you feel that your own experimentation fed into the research? Because I think earlier in the conversation you mentioned two other students. One was David Lloyd and the other was something Hoffman. What was the name?
Yeah, Andy Hoffman.
Andy Hoffman, right. And, I think that sometimes self-experimentation is viewed as being unscientific or separate from scientific research, but there's no question that the two can play off of each other in a very constructive way.
Yeah, I don't think that we so much focused on our, what we called large animal bioassay, the limited experimentation that we did on our own. But certainly it locks in well with the various projects that we were doing. Most importantly, with the work with empathogens, where you can feel a difference between a stimulant and a drug like MDMA or MDDB and a psychedelic like DON. It was obvious to anybody who had some experience with those compounds that they were not the same class of drugs. It has long been known that stimulants were a separate class from psychedelics. In fact, the whole name of hallucinogenic amphetamines was meant to distinguish the phenethylamines from the stimulants like methamphetamine and amphetamine. So yeah, I would say that there was a nice correlation between what we were seeing outside the lab and the data that we were getting from our lab studies. And that was further encouragement to depend on the drug discrimination assay. It was working out so well.
Right. And another motivation in a lot of that research seemed to be to mitigate the potential neurotoxicity of MDMA.
Yeah, because George Riccardi had published that study on MDA from the University of Chicago that showed the neurotoxicity that had been seen previously with methamphetamine. And that threw a big wrench in the gears of all this excellent fueled enthusiasm for developing MDMA as a therapeutic tool. So as far as the neurotoxicity being a knockout punch to the further development of these agents for therapeutics, Dave always saw it as critical to come up with another compound that produced the same pharmacology without inducing the toxicity. And MDAI was a big step forward there.
And Riccardi's research aside, what is your understanding? Because there's a few different models of MDMA neurotoxicity that have been discussed in the scientific literature. And it's still a very controversial issue. I mean, there are people that seem to firmly believe that none of this has any validity in humans and that it is essentially non-toxic when used in a semi-responsible manner. And then there are other people who think that it's therapeutically irresponsible to use MDMA because of the literature on its neurotoxicity. What's your take on that research?
Well, I think it was obvious from the beginning, anybody who's been in pharmacology, toxicology, that any drug can induce toxicity when you crank the dose up high enough. So there was always the dose factor that the hardcore denialists were refusing to look at. You know, if you have neurotoxicity at any drug level, they would argue it's irresponsible to use it at lower doses when you might be inviting disaster. But I'm of the school that says that dose is everything, that given in proper doses at fair intervals, you know, it's very important to not do it excessively all at one time, day after day after day. But as long as there's time in between, that's the critical point. I think, you know, there was a lab at the University of Chicago who George Riccardi worked for. His name was Lou Seiden, who was a very nice guy. People loved Lou, and he had been in the field for a long time. So he was at the helm of this neurotoxicity issue, and it's hard to argue with a guy like Lou Seiden. And then, of course, Riccardi, after he went to Stanford and got his neurology residency out of the way, he established his own lab at Johns Hopkins. Got a lot more work done on this issue. But it's great to see it now, you know, on the verge of MDMA becoming a accepted drug for treatment. It's really great. I'm really satisfied that the neurotoxicity issue didn't permanently get the legs out of the area and allowed for further research to be done.
Yeah, I am too. And I also just, you know, I find a lot of the literature sort of confusing because it's characterized in so many different ways. You have some literature that describes, you know, a lasting decrease in serotonin or some serotonin metabolite like 5-hydroxyindoleacetic acid, however many weeks after administration. There's the literature dedicated to the idea that the uptake of dopamine into serotonergic neurons is responsible. Then there's that literature on these cysteine conjugates that come from some kind of alpha-methyl dopamine metabolite. And it seems like there's not a lot of agreement on the mechanism or the clinical relevance of that toxicity.
Yeah, I agree. There was a lot of aspects to look at, and certainly the dopamine terminals were critically important. Imagine getting a gush of serotonin in an area where you got dopamine terminals, and have the dopamine terminals take up the serotonin or the metabolites of serotonin. That was something to think about anyway. But as far as I know, they've never really come down with an overarching theory of why these changes take place. But I think there is fairly good evidence that at the therapeutic doses and the frequency of administration that would be used in therapeutic realms, it doesn't seem to be a practical problem.
And you were also one of the first people, if not the first, to do work with the methylene dioxyaminoindane, right?
Yeah, that was part of our research effort. We made the indan and the tetralet derivatives. And yeah, the indan looked really good as far as producing hardly any neurotoxicity at all. And that Mike Johnson, who was working in our group at the time, went on to work at Lilly Pharmaceuticals. He was the lead investigator on that part in our group. And then I would do the drug discrimination. So that was, I remember we were going to be presenting a poster at a Society for Neuroscience meeting. And we had the data up there for the aminoindane. And a gentleman walked up to me, and he had this really disturbed look in his face. And he said, I think it's irresponsible that you guys are presenting this data. And I said, why do you think that? I said, well, now people will go back and make this drug and take it.
Huh.
So I thought, yeah, well, you got a point. I wasn't going to argue with him.
I mean, he was right. People certainly did make MDAI. It became a somewhat popular research chemical for many years.
Yeah, I never really found it to be that interesting. Didn't seem to have like an entactogen, but I understand other people did find that it did produce entactogen effects.
Well, some people even had this idea that if you combined a selective serotonin releaser like MDAI with a dopamine reuptake inhibitor, you could create an experience that mimicked MDMA without the toxicity.
Yeah, that makes sense. That the unique effects of entactogens are not solely due to serotonin, but there needs to be some dopamine uptake inhibition as well. So that would fit in with that part of the theory. Makes sense.
And was there something when you were doing all this research, which was very diverse, I mean, you were working on LSD structure-activity relationship, MDMA structure-activity relationship. You're doing all sorts of different things. Was there something that you were passionate about or you felt was like a mystery you wanted to solve?
Well, Dave was always really hot on the lysergimides because other people had done research on phenethylamines, and fewer, but a good number of people were also looking at tryptamines. But very few people had continued to work on lysergimides. So that was always a big effort for him. We had access to lysergic acid. We could use starting material to make a variety of lysergimides. And Andy Hoffman, as part of his main project, was looking at the N6 substitution. It has a methyl group on LSD, and he made a series of analogs that had ethyl or isopropyl, what he called the LADs, which we always thought was the preferable acronym for the lysergimides, since we're not in Germany, so it's not lyserg sour, it's lysergic acid diethylamine. So anyway, I got into it. Dave wrote it in a grant and was really curious about checking out the diethylamide substituent. And it was clear from the literature that if you substitute the diethylamide with dimethylamide or any other alkyl amide group at that CA position, you diminish activity pretty significantly. And his thinking was that there was a steric hindrance problem with bigger alkyl groups. and that we could use one of Dave's consistent methods of investigation was to focus on stereochemical aspects. So the idea was to start with the diethyl amide and bridge the first two carbons to form an aziridine ring. So it's a 3-membered ring with the nitrogen of the amide and 2 carbons coming off that were connected together. And then add the extra carbon headed off on the first carbon. So you'd have a dimethyl aziridine, 2,3-dimethyl aziridine. And then there were 3 isomers that you could get if everything worked. And one was the RR and SS, and then the meso compound, 3 different stereoisomers. And that would be a beautiful study to show which one had the greatest potency, would tell us something about the spheric allowance of that position in LSD as it bound presumably to the 5-HT2A receptor. So I was given the job of making that aziridine derivative, and I could not get it to work. It would form, you'd see it on the TLC plate. By the time you worked it up and isolated it, the aziridine was gone. Couldn't see it on NMR, and tried a couple of different approaches to changing the reaction conditions. But Dave figured out that the final compound was chlorinated. He did the flame test with a green flame. And the conclusion there was that the phosphorus oxychloride we were using as a dehydrating catalyst in the amidation reaction, the free chloride ions were attacking the aziridine, which is a very strained system. We refer to the ability to break up the ring because it's very strained, which was known. Plus, the nitrogen was it was an acyl nitrogen, which gave electronic help to breaking up the 3-membered ring. So at that point, we characterized the compounds that we did add, which contained the chloro group, and just tested those compounds. And we did see some difference there and published that in a separate paper. But that was an interesting project, but I regret that the steric hindrance was insurmountable. I think Dave went on to test the 4-membered ring.
Yes.
Some other, I think Stuart Frescus worked on that.
Yeah.
So that was that was my challenge. It was my project, and I was determined to make it work, but I wasn't in the long run able to do so. And I don't think anybody else has done it since then, so I don't think it was just me. I think it's the chemistry.
Oh, yeah. I mean, and it must have been very exciting to be pushing the limits of chemical possibility with pretty much the strongest known psychedelic. I mean, I just for the first time started working with derivatives of LSD, and it's very exciting to even start in that area. The potential for the power of the final compound is really impressive. I mean, there's really nothing else like it. It requires a level of caution that you don't otherwise encounter. So that must have been a lot of fun. I mean, that was the first time you'd ever worked with Lysergimides, making these aziridine compounds or attempting to make them?
Yes, for me it was. But like I said, my lab partner was working on the N6 series. So we had Lysergimide going on in our lab. A lot of it was, every time you had a reaction that didn't give you what you wanted, you just feel sick about wasting that Lysergimide starting material. That stuff was precious. So we would do the reactions on pretty small scales. And after I had tried and retried making the aziridine a few times, it was hard to justify going on doing it. You just feel like you're burning up this wonderful starting material, precious starting material. Where did
it come from, the lysergic acid?
I believe it came from Sasha. That Sasha had gotten it from, I don't want to speculate. I believe it came from Sasha. put it there, leave it at that.
And he hadn't done, as far as I'm aware, I don't think he did any research on the Lysergimides. Am I wrong about that?
No, to my knowledge, he's never published anything.
So that's interesting. I mean, that must have been very exciting.
It was.
And
it was really exciting.
And you said you published on the chlorinated derivative. I'm not sure I'm familiar with this publication. What was the compound?
Oh, I'll have to go back and look at it. It's not coming back to me right away. But you will see in my thesis that I wrote out this diagram that showed how the chlorinated derivative would open up the ring and give you these isobutyl derivatives. So I think if you check the thesis, it'll all be in there.
Right.
I'm going to pause momentarily for an ad. This podcast was also brought to you by matcha.com, a source of organic, high-quality, heavy metal-tested matcha from Japan. This is a company founded by psychedelic pioneer and matcha aficionado Andrew Weil. They have a variety of interesting matchas, including freeze-dried matcha cubes and a matcha sampler pack. All products are 20% off if you use the code Hamilton. I especially recommend the freeze-dried matcha cubes. They are calling Space Matcha. It's very delicious. It dissolves instantly in water, and you can even dissolve it in your mouth and use it like a snack. It's a very futuristic product. I carry a bag of them around in my backpack. If you visit matcha.com and use the code Hamilton, you get 20% off and a free gift. Thank you very much, matcha.com.
Right. And then you were also doing work on DOBU. That was your project as well, right?
DOBU. Oh, yeah. In fact, that was my original project. There were DOM derivatives. And it was always, again, Dave's thinking was that you could test the steric interference with the drug serotonin receptor binding by checking out different side groups. So DOM, of course, has a methyl in that position and is active in humans at a 5 milligram dose. And it lasts for a long time because it's metabolized very slowly. So Dave had hypothesized that we DO-ethyl, substituting an ethyl group for the methyl at the 4th position, was still pretty active, maybe even a little more active than DOM. And the straight chain propyl group was active, but those groups didn't really present any steric hindrance to the receptor because they could swing out of the way as the alkyl group rotated. It could rotate out of the way when the drug bound to the receptor. So his idea originally was to make the DO isobutyl. I renamed that compound DOiB because isobutyl can be seen as a Y. So instead of DO isobutyl, I called it DOiB. And that would present steric hindrance at the end of the alkyl chain. And then to look even more closely at the situation, we made the DO sec-butyl, where you could view the iso or the propyl, DO and propyl. Through the isobutyl, the ester methyl is connected to the 3rd compound from the ring, whereas the whereas the sec-butyl had the methyl coming out of the
first carbon.
First carbon of the chain. Right?
Yeah.
So the sec-butyl should present more of a steric hindrance as it rotated around that bond. And then we ended up, that was a really fun chemistry project to work on. Because how do you make isomerically pure alkyl groups, phenylalkyl groups like that? So we had the good fortune of working at Purdue, where we had a Nobel Prize winner, H.C. Brown, who had developed these isoborane reagents for making stereochemically pure derivatives. And I hooked up, had a wonderful postdoc over there who worked with me. They were very generous, let me work in their lab, and made my own reagents there and ended up getting it to work. where we got really pure DOsB.
Yeah, tell me about that specific process of resolving the enantiomers. How did you do that?
Oh man, that was a long time ago. But in general, I mean, the borane compounds are connected to big carbon skeletons. I believe it's called isopynocanthal borane. So the boron was really there to hold the skeleton in place. And you could make plus or minus isopynocanthal borane, where that big alkyl group would stretch out to opposite sides of the borane molecule. And then if you use that as a reducing agent, it'll reduce the double bond from one side or the other, depending on which isomer of the borane you're using. So the beautiful thing about that chemistry also is that you can predict which one produces the R and which one produces the S isomer. And then you know not only the relative stereochemistry, the plus or minus, but you know the absolute stereochemistry, whether the plus is R or the plus is S. And that's really critical for making determinations about how the molecule is interacting with the receptor. And this was at a time when very little was known about the exact receptor topology. I know so much great work has been done since then, identifying what the 5-HT2A receptor actually looks like. And I believe you talked to Brian Roth, who was critical on that.
Yes, yeah.
So it was really interesting to view at the point. The pharmacology of psychedelics had gone through somewhat of a renaissance during the time I was at Purdue. When I first got there, there was the leading theory was proposed by a Yale neuroscientist, a guy named George Chagajanian. And he was hypothesizing that the psychedelics didn't work as direct agonists, but rather worked indirectly at the serotonin receptor. And that was shown eventually to be wrong. It was really a direct agonist effect. It may not be a full agonist, but it is a direct agonist at 5-HT2A. So it was kind of mimicking serotonin. And so much evidence came to support that over the years that it's fun for me to look back and think, oh, we thought it was an indirect agonist back in the day.
Right. I think that's
pretty exciting when you see about major interests in science, how they evolve over the years with additional information, additional work.
Well, I think that's one of the things that people don't often appreciate about psychedelics is I think there is an understanding that on a psychological level, these are substances that can be used to teach us about ourselves. You take a psychedelic, you have an experience, and you learn a little bit about who you are, why you feel the way that you feel, what you think about this or that. But on another level, there are tools for understanding ourselves on a molecular biochemical level. I think that's kind of one of the most amazing things when I look at your research and you're thinking about the stereochemistry of this methyl group and the sec-butyl and how it interacts with a specific amino acid residue or this or that. It's like these are tools that are teaching us about the architecture of our own brain and by extension consciousness.
Yeah, I think psychedelics are unsurpassed in what they can teach us about human imagination, human self-introspection. And yeah, there's a certain danger to them. Bad trips certainly do happen. But even those can sometimes teach us things that we wouldn't gain access to otherwise. That was one of the things that got me really interested in psychedelics from the first time I tried them, that there's so much to learn there. It's such an interesting field of exploration. So in order to develop more agents, I was always really weary of doing street drugs. I didn't want to do any street drugs. So it was a magical thing for me to get accepted into DOiB's group, where I learned how to make drugs, not just to test drugs. But I think that was always one of the things that you have to admire Dave for, was his insight into the molecular interactions. And it always impressed me that when he put a theory out there, it was usually right. When we made the compounds, test the theory, he was right on. So he has just an excellent insight into molecular pharmacology and the study of the human mind.
Absolutely, yeah. And back to the culture of the lab at that time, which I think is really interesting. I mean, obviously, this sort of research attracts people who have had psychedelic experiences, and those experiences were meaningful to them in some way, and they want to learn more about it, and also are scientifically passionate about the subject matter. So what was that like? What was the scene like among graduate students, Reagan administration, in one of the only labs on the planet doing this type of research? What was that like?
Well, I think we all felt very honored to work there. And at most, maybe, Dave typically had about 6 or 7 grad students at any one time. And usually there were only three of us who had a consuming interest in the drugs. The other ones were hardcore chemists. A lot of them, a guy from Taiwan, another guy from India. And most of the grad students weren't interested at all in the societal effects, the things that were important for us who grew up in the 60s and 70s, were well aware of the influence that psychedelics have had on our culture. Protesting the Vietnam War, it just suited so well. So for me, I felt like I was where I wanted to be. I was just so thrilled that I applied to go to school at Purdue and got accepted. Eventually got into Dave's group. And between Dave and Andy, Dave Lloyd and Andy Hoffman and me, Sasha began referring to us as Dave's Three Musketeers. So we were the 3 graduate students who were in on it. The rest of the guys, they didn't really approach us. They didn't really want to know anything about it. And even, the graduate students of the other professors in the department didn't really want to know. They didn't ask any questions. I mean, we got along with everybody. We were all good friends. So as long as that was the case, no questions were asked. And I think a lot of that had to do with Dave's lead, because not only was he a brilliant scientific researcher, and he was a very good teacher. I think the pharmacy students liked him. Those who didn't complain about being too hard. But MedChem was always the hardest course in the pharmacy curriculum. You just got to live with that. But Dave really worked hard in the department level. He was chairing committees. He was very active in doing the stuff that keeps an academic department running. So I think he was very well respected by the other professors. So it was never a challenge. If people did talk about these strange graduate students, long hair and beards, working in the committee, working in the pharmacy school, they never mentioned it to us. It was always, everything was normal.
And at some point,
I think Purdue, yeah, go ahead.
But at some point, you did start doing self-experiments as well. Whether or not it was sanctioned, I imagine it doesn't really matter either way, I suppose. But did that inform the research? I mean, that's another layer of this. Of course, the greatest figures in this world, Shulgin and Hoffman, were very passionate about self-experimentation as a way of better understanding the scientific research they were doing. So you have these 2 amazing role models that have shown how much can come scientifically from self-experiments with the compounds that you're studying. At what point did you begin to test these compounds on yourself?
Let's see. I think it really grew in earnest. One of the first projects that I had was the the 4 isobutyls, the 4 alkyl that we were talking about earlier. And I did want to try one of those to see what it was like. And it wasn't a pleasant experience at all. It lasted way too long. DOM lasts 24 hours, but I think I tried a small dose of the isobutyl compound, and it went on for 3 days. And that's never a pleasant thing. And it wasn't particularly pleasant. It had a dark mood to it. So that really taught me a lesson to not take these things on casually, that you should always hold respect for them. Dave always had the comment that you're kind of damned if you do and damned if you don't in this field. Because if you do try the psychedelics, get a feel for their activity, you may be criticized for losing objectivity in evaluating their activity. But if you don't ever try it, then you could be criticized for, not appreciating the activity of the compounds you're working on. So you're kind of damned if you do and damned if you don't. It was clearly the best route was to stay low-key, don't talk to anybody about it, but try it and use your best judgment. Most important rule is always have somebody there who isn't doing the drug in case things go south. But for the most part, it was pretty clear sailing. And that increased more once we got into the adaptogens and started evaluating the isomers of MDA and MDMA and then MBDB. Then we really felt like, our experiences were important to document whether this adaptogen theory is indeed correct. And I believe, I should mention this, but I think we at one point set up a double-blind experiment with a few of us that we laid out some of the S isomer, R isomer, MDA, MDMA, MBDB, and we set aside some time to try it and then have it double-blind. You didn't know what you did at the night of the experiment. Then afterwards, you would open up the double-blind and see if it was what you thought it was. So that was the most organized it ever was for the 3 of us working together. And that was an interesting experiment. I think we all were very aware of the risk involved. You hear people doing acid and never returning back to their normal self. And we're well aware of that and very careful not to be very careful that didn't happen, that we didn't take any high doses or did everything possible to avoid that kind of situation. So in retrospect, I think we did all right.
Are the reports on the 4 butyl derivatives that are in PCOL, are those written by you?
I don't know. I'll have to check it out. We probably sent some to Sasha, but I don't know if he ever did it. He might have been curious because of his background with DOM to see what happened when you extended the alkyl group there. But I can't recall as I'm sitting here if he ever did or not. A lot of the communications between Sasha and Dave never made it down to us. They had their thing going on there.
Well, I mean, are the reports that are in PCOL written by you?
Oh, I'm sorry. I don't know. I'll have to go back and check. I don't remember.
Because some of the reports are from you, right?
Yes, some of them. Although I can't remember offhand which. But yeah, there were some. And I think as a rule, we did, when we did test something, we had an experience to relay, we would write that up and send it to Sasha, so he was always aware of what we were doing.
Well, that in and of itself must have been an honor to contribute.
Indeed it was. Sasha was a unique person in this field, as your fans are all well aware, I'm sure. And when I finally graduated and moved to California, he was just such an endearing figure. He was so nice to me, so generous with his time and his guidance. And it was really a pleasure for me to get to know him better in the early 90s when I first moved out there.
Yeah. Yeah. It must have been amazing. I mean, it must have been an amazing time to know him when that was the time when he was writing Pikal, right?
Yeah, absolutely. I remember when Pikal first came out. And of course, Anne was such a delight. They had lots of picnics at their place out there in Lafayette. And he would introduce me to other people, chemists. I think it was always important for Sasha that the chemistry stays ongoing in this field, that we don't lose out on new people doing chemistry. So that was his wish to go on. And I think he and Anne had a program going on. They were encouraging people to meet and discuss psychedelics, get on board.
Yeah. And do you want to talk about the Pyre incident? Is that something?
Well, sure. Maybe it would be a story of warning to some of your listeners that weird shit can happen. And this came, had a really interesting time at the Esalen Institute one year, where some guys from Johns Hopkins came out with a bottle of 5-methoxy-DMT. And Andy and Dave and I, we got a late invitation to this Esalen meeting. I believe it was in June of 1985. And they had been working, I forgot the name of the psychiatrist who was in charge, but they had been working with 5-methoxy-DMT, smoking small amounts of it. And I think George Greer at the time was interested. And we didn't have a room in the big house, but they let us set up a big tent. We had a 3-man tent that we could set up on the lawn at Esalen. And at the time, there was some bad press came out about people in the baths at Esalen who were doing drugs and got into some trouble. So the people who ran the facility were insisting that we do not do drugs on campus there. You know, if you want to do something, go off to the Big Sur Inn or someplace else. Don't do it on the Esalen campus. But since we had our own tent, it was determined that we could, if we were cool about it, we could just do stuff there. So our tent became like a launching pad. We had 3 sleeping bags laid out. And a number of us had tried this substance, smoking about 10 milligrams out of the pipe. And the instructions were take a good hit, keep it in, and lie back down and slowly let it out. Now, if after that you feel like you can lean back up and take another hit, do so. But you'll know when it's time, when you've had the right amount, you won't even be thinking about that at all. So that was just an unbelievable experience. You know, I had tried DMT and other tryptamines, but they were nothing like inhaling a good dose of 5-methoxy-DMT. There was something experiencing heaven. And it only lasted for like 2 or 3 minutes. And then within 5 minutes after that, you were back to feeling normal. So the stuff was obviously metabolized quickly, but the peak experience that it induced was just beyond anything that I had experienced before or since. So I was really interested in 5-methoxy-DMT coming out of that meeting. And at the time, it wasn't a scheduled drug. You could just order a 5-gram bottle from Sigma Aldrich, and they would mail it to you. So I turned on a couple of my friends back at Purdue, and we were all very interested in working on maybe some other compound in a series based on 5-methoxy-DMT that we could discover that had been tested before. And quickly we came up with a target drug, and that would be 5-methoxy-DMT, except the dimethyl group on the amino is substituted by an extra carbon on each side bound together into a 5-membered ring, pyrrolidine. So instead of having nitrogen, methyl, methyl, you had nitrogen, carbon, 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 4 carbons all together bound into a 5-membered ring. And that seemed like it would be worth a try. We were aware that it was new territory, and we were careful with it, but we did some initial experiments at very low doses, and it seemed it wasn't like 5-methoxy-DMT. You didn't have any consciousness to experience anything. You were just out for like 3 hours in those initial experiences. So I decided I would try it, and looking back on it, I would have done it much differently if I was doing it today. But I had a good friend, and he and I went into a separate room, and we were going to sort of, since we were both doing it, it's not like we had a sitter. But there was another friend who was in the house, and I had assumed incorrectly that he would be there in case any of us came out who needed help. But he left shortly afterwards. And my experience was I did my hit and laid down, and I didn't pass out, like I wasn't unconscious, or I wasn't certainly experiencing altered consciousness in any state. My friend, he was out, and he just stayed out. And I got up out of my room, and I remember walking around the house for a little bit, and the next thing I remember was I woke up in a jail cell. Now, it happened to be that this was a holiday at Purdue. It was like a spring break party, and they had these go-kart races, and the campus was partying. It was a Saturday night. So what I apparently did was I decided to take off all my clothes and go walking across campus. Not something that I would normally do. And I got picked up by the Purdue police for indecent exposure. And the jails were kind of packing there because a lot of students were being brought in too drunk. So I got transferred to the nice new county facility, Tippecanoe County. And I woke up wearing a scrub suit, laying on this bed, and feeling really comfortable, really good. But I didn't know where I was or how I'd gotten there. I noticed there was a speaker on the wall with a button. So I pressed the button, and I heard a voice say, "Yes, what do you want?" And I said, "Hi, I don't know what I'm doing here." He said, "Okay, hold on," because they brought me in. I was unconscious, and they just, set me up in this jail cell. And I came out, and I expressed wonder, much to the amusement of the police officers who were there. They were just laughing at me. And I said, "I don't know how I got here." And they said, "Well, you were brought in." And I said, "Okay, can I get my clothes back? Can I make a phone call? Maybe put up bail, whatever's necessary?" And the guy started laughing, and he said, "Buddy, you don't have any clothes." So that was a wake-up call. Anyway, I made a call to my friends at the Waldron House, and they came out and took care of things, brought me back home, and I was just freaking out. I thought that this would be in the news, that I was going to bring disgrace onto the Nichols crew. So I decided I would try my best to make sure that my case doesn't come up. And luckily, at the time, the county prosecutors, they had hours set aside that if you had an issue to discuss with them on an pending court case, they would listen to you. So I came in, I dressed up in a suit, tie, and came in, and I told the prosecutor that I had a really bad night, hadn't been sleeping well, And I don't remember anything that happened that night. And he saw that I was sincere, and he thought about it. At first, he read the police report and laughed. It was sort of the police and the lawyers were not really out to get me. They were just abused by the whole story. You know, I wasn't a problem for anybody. I didn't act up. I certainly didn't fight. So he said, okay, why don't we do this? I'll come halfway if you come halfway. I want you to see a neurologist and get an MRI done. And if the neurologist tells me that your brain is healthy, that this is not likely to happen again, we can just write it off as a one-off experience. But if there is something that needs attention, you are giving me your word that you'll take care of it. And I said, absolutely, really appreciate it. So I got the MRI, and it was clean. And the prosecutor told me that he would make sure that the case doesn't go to court. And he needed the permission of the judge in order to do that. So luckily, it didn't go anywhere further. But needless to say, Dave was totally freaked out. And he talked to Sasha about it. And together, I think they decided that maybe I was a postdoc at the time. And I wasn't sure what my future plans were, but that was an indication that I needed to move on. That I had, broken the rules. There was no way that I should have gotten into that situation, and that Dave needed to separate himself from me. And I understood that. And I actually, volunteered to leave. And he was very relieved that he didn't have to tell me to go, that it was my decision to leave. Anyway, a cautionary tale to those who are interested to don't try to, or always be careful to follow the rules when it comes to testing new drugs. Always have somebody there who's watching you, who isn't part of the experiment, who can prevent things like that from going on. I still thank my lucky stars that it turned out the way it did. And I got a really good job teaching in California, so it was a good time to leave. And worked out well for me. But boy, it was really scary. And I felt really ashamed that I had brought this kind of potential disgrace on. Be careful with those tryptamines.
Right. And I think that this is a fascinating story because on one hand, yes, it's a cautionary tale. Always escalate the dose very slowly. Always have somebody with you to protect you if you're working with an experimental substance. I think that's one level of response to the story. But on another level, like you wouldn't think it, but I think this shows the importance of self-experimentation as well, because this is a compound that had been in the scientific literature since the 1960s. People were aware of 5-methoxypyrrolidine tryptamine. It was a known compound, but it was not known that it exerted a very different type of activity from DMT. That it wasn't just a more potent psychedelic, but it's, I think, qualitatively an entirely different type of psychedelic. You have these substances that seem to preferentially bind to 5-HT1A, and instead of producing a sort of classical psychedelic experience, it seems that they induce something closer to a dissociative fugue.
Good way to put it.
And I don't think anyone would have been aware of that unless someone like you had tried it.
Well, I think you've got a good point there. And has anybody discussed it or published anything since then of the human pharmacology? The effects?
Well, some of the most selective known 5-HT1A agonists are 5-MeO-pyrrolidine tryptamine derivatives. And I think those were all synthesized in the Nichols lab after you left.
How do you like that?
They're 5-methoxy-4-fluoropyrrolidine tryptamine derivatives that are extremely high affinity and selectivity for 1A.
Okay, so it's a 4-fluoro instead of a 5-methoxy.
But it's both. It's substituted in both positions.
I'm not even going to look up on that. I think I've had my contact with the drug, and I'll just leave it where it is. But it's nice to hear you say that something positive might have come bringing attention to the drug.
Absolutely. And your experience is published in TCall, which is the greatest imaginable honor. I mean, in terms of a bad trip that results in inclusion in the greatest scientific publication that will teach, generation after generation about the psychopharmacology of this compound. I think it could be a lot worse, although I can imagine how it must have felt catastrophic at that time.
Yeah, it was a tense situation, but it brings joy to my heart to hear you tell me that aspect of it, that there was some positive results that came out of it. Certainly the tale of warning is the main thing that I wanted to get across. And that's clear. I guess Sasha even mentions it in the TCOL. Let that be a warning. This illustrates why you need a sitter. You need somebody there who's looking after you. So anyway, nothing to be done about it now. It's over 30 years ago.
And I just checked, and yes, it was in 2001. David Nichols published a paper, a novel fluorinated tryptamine with highly potent serotonin 5-HT1A receptor agonist properties, and it's the 4-fluoro-5-methoxy-pyrrolidine tryptamine. So there you go.
How do you like that? I haven't been following it.
Yes.
I doubt if anybody tried it, though.
Well, I think that,
I don't know.
Yeah, I mean, I would imagine people are going to be very cautious with those compounds as a result of your experience and what is described in TCOL. And it's so funny talking to you about this because, I remember, I think it was the first time I ever met Dave Nichols. I was probably 21 or something like that. And I asked him, I had to ask him, well, do any of the graduate students in your lab ever try the compounds that you research? And he said, well, there was this one guy and he smoked the 5-methoxy-pyrrolidine tryptamine. And I could be wrong about this, but I think he said you called it the Mina bird. Am I remembering that correctly?
I did. I referred to it as Mina bird.
Yeah. So he told me that, and he said that it was pretty disastrous. And then, I read the report in TCOL, and then to actually meet you, it was like this amazing experience of, wow, that's the guy.
I don't know if that's good or bad.
It's good.
Take it for what it's worth.
It's good for me.
It taught me a lesson, and thank God nothing too serious resulted from it.
Yeah. And one of the things that's really interesting to me about 5-MeO-DMT is you can have this experience, when you think of a classical psychedelic experience, you have certain revelations, psychological revelations. Maybe you become aware of the fact that you will die one day. Your time on earth is finite and you have to be kind to other people and you have to treat other people well because one day you'll be gone and you want to leave something good behind, or you want to show your parents that you love them or your family that you love them or something like that. And you come out of it and you have an increased appreciation for something, your family, the natural world, your friends, whatever. But what I find so interesting about 5-MeO-DMT is that there's none of that psychological, intellectual content present in the experience. For me, it was a completely empty experience. There was no revelation. I simply lost consciousness in every sense of the word and came to overwhelmed with gratitude to be alive.
But you didn't have a particularly pleasurable experience, or
it was
overwhelming?
I whited out. It was
unconscious.
I was unconscious. And so it was as if it sidestepped all of the psychological dimensions of the psychedelic experience and cut right to the gratitude for life without getting to the solution of the problem without working through any of the intermediate steps, which I found very interesting.
That is interesting. Yeah, everybody I knew who tried it had a very deep awareness that they were in this moment of eternity and came out of it with that awareness intact. So to not experience that, it's kind of a shame because it was a very pleasant experience, overwhelming. Maybe pleasant is a wrong term to use because it was just so overwhelming, but very positive.
Right. And And you even, I don't know all that much about your career post Nichols lab, but you were one of the people, if not the person that discovered Vyvanse, right?
Yeah. I ended up working at a small startup company called New River Pharmaceuticals. And we were into making prodrugs. The original goal was to make a polymer version of thyroid hormones. And that didn't work. That wasn't going to work. But we did get involved in making amino acid prodrugs with the goal of making oxycodone resistant to abuse. So we figured if we had an amino acid on oxycodone, this was when OxyContin was really hitting the presses for the first time, around 2000, 2001, that we would make a drug that needed to be hydrolyzed in the gut by digestive enzymes. And if you tried snorting it or injecting it, it would release the oxycodone. It would stay a prodrug. So we started a research effort to make a series of different amino acid prodrugs of opioids. And then we had to submit an application for a Schedule II license. So the lawyer working on it asked us to write up a list of all the Schedule II compounds that we might want to work with, so that if we do select one of the other ones, we would already have the DEA permission worked out. So I immediately thought amphetamine would be the number one, because at the time, Adderall was the standard. And Adderall XR had come out, but it was going to go off patent pretty soon after that. So I put plus amphetamine on the list. And then there came a time where we said, okay, let's see what amphetamine will do. So I took the project up as a drug discovery effort to make different amino acid prodrugs of plus amphetamine. And then we tested them in rats for pharmacokinetics. And sure enough, we found that the lysine provided just the pharmacokinetics that we were looking for. And then the rest of the group took up the development of the drug. And we even did a lot of the clinical trials as part of New River Pharmaceuticals. And Shire partnered with us toward the end. And then once the drug was approved, they bought the whole company. And Vyvanse still has not gone off patent, which is really remarkable.
And it's a huge hit.
Yeah, it's a blockbuster. So that was always something for me that was very rewarding, that I worked on a drug that made it to the market, not only made it to the market, but became a blockbuster. And it kind of reassured my past work with amphetamines is paying off more than just getting me a PhD, but gave me some critical experience that I could apply later.
Right. And just a sort of logistical question, I read an article in the New Yorker years ago about the chemists that discovered ambien, and none of them received royalties for ambien after it was released. And one of them was so embittered that he left science to become a lawyer to defend medicinal chemists who were cheated out of royalties for the drugs that they discovered.
I know. I don't see it that way, because when you sign up to work with a company, it's in the contract that you will not own the patent rights. That should, whatever you discover is the property of the company. So I went into it knowing that, and I accepted it. I wasn't embittered at all. The worst thing, though, was the politics inside the company. There's nothing else that we had worked on worked. And there was, let's see, I think it was John F. Kennedy who said that success has many fathers and failure is an orphan. So I just wrote it up to that. There was a lot of feuding between the scientists. And while I was assured I'd get my name first on the patents, that didn't work out that way. I wasn't really in a position where I could argue with it for political reasons inside the company. But I did get some stock shares and made some money at it, but nothing like the money that Shire made from it, now Takeda. We didn't know that it was going to be a blockbuster, but the timing just seemed right. It was just a really great project to work on because everything was looking good from the beginning, and I thought it had a much greater chance of success than coming up with an opioid. Interestingly, the guy who won the political battle claims he was the primary inventor of Vyvanse, started his own company called ChemPharm, which is being traded actively now. And he's got a amino acid prodrug of methylphenidate that's just approved by the FDA.
Oh, I saw that. That's a very interesting prodrug. Do you have any insight into the structure of that? It's a very odd structure.
I think it's in the patent literature. I know it's a serine. He attached the serine to methylphenidate. But in terms of the pharmacy, I just don't see that in order to get an initial effect, he had to use methylphenidate itself, immediate release. That would start working right away. And then the serine methylphenidate would get metabolized and kick in after a few hours. But it doesn't seem to have any benefit over Concerta, the formulation of methylphenidate that was popular for so long. And I just don't see why an insurance company would pay for it versus generic methylphenidate. But I try not to let my personal feelings get in the way.
Right.
But that's what happened afterwards. And he based his whole company. He just Xeroxed pretty much what New River Pharmaceuticals did and did the same thing with his company, with ChemPharm. So he's off and running with that.
Given your experience in psychedelic academic research and industry, and now this new world that's emerging of industrial psychedelic research, do you have any thoughts about what might be coming around the bend?
Wow, that's a good question. I don't know how to answer that. I'd like to think on that. But one of the things that was always apparent with the study of psychedelics is there's lots of room for surprises. It's likely that whatever comes around the bend, something that wasn't thought about at a time, just surprisingly popped out. And as far as drug classes go, I think the psychedelics rank up there as one of the most potent potential new drug source because they do so many wonderful things. And I can't name anything in particular. Certainly in psychiatry, there's lots of benefits that can be seen, different models of usage. But I really like, what people are doing with psilocybin. I really think that drug has a ton of potential. I guess they're looking at it for depression. And it's good to see that they're not just giving it alone, but it's in the process of therapy where you have a therapist who sits with you on it. I was really happy when Roland Griffith got involved. I always liked him. He was a behavioral pharmacologist from Johns Hopkins, and I knew him. And he was just always a very cheerful, very encouraging guy. So when he took the reins of the research being done at Johns Hopkins, that was really something that I was very happy about. I was glad that panned out. And now with psilocybin getting so much respect out there, especially in the business community, it's wonderful to see. And I doubt if that'll be the last one. I think there'll be other surprises down the road. I'm not ready to predict what they would be, but I would just say stay tuned, folks.
What about, given your work on prodrugs, do you think there's any way to make a DMT prodrug that would be orally active? Something that might...
Yes. Yeah, I've thought about it, and I think that would be worth checking out. I don't know what the effect would be, maybe by spreading out the active the fact that it has the benefits and the uses that it does. But I definitely think for a while I was thinking that just making a prodrug of psilocin would be a benefit just as a way to get the drug reclassified in terms of its schedule status. So, when a drug is brought before the FDA as a new drug, it's their job to classify it, and psilocybin should never have been Schedule 2. But if you make a prodrug of psilocin, another prodrug, since psilocybin itself is a prodrug, it might be a way to get a Schedule 4 licensing on the new compound because it went through its own development program. So I really like the benefits of prodrugs, and in contrast to what Travis Nichols says, prodrugs have been around for many, many years. And it was always funny to me, just to go off on one tangent. I was looking into prodrugs of phenethylamines when I started working on the amphetamine project. And I came across a drug called mitodrine, MIDODRINE, which was used for orthostatic hypotension. And at the time, it was most readily used by astronauts returning from the space station because they had problems with getting back into gravity. When they got up out of bed, their blood pressure would drop. They'd have to go back into bed. So they were taking mitodrine to keep their blood pressure up. And the mitodrine was a prodrug. It was a glycine prodrug of a dimethoxyphenethylamine compound. So here, Shire had the rights to that prodrug. And the mitodrine prodrug was very much similar to amphetamine itself, yet nobody in their research organization thought to make a prodrug of amphetamine. It would have, I always thought that was kind of funny. They had it in their lap the whole time. Could have saved themselves $2.6 billion by developing it themselves.
Oh. And did your time in the Nichols lab overlap with William Leonard Picard at all? Or did he come after you?
I think Dave knew. I really don't know anything about that. I found out about him. Wasn't he the guy who was working out of these missile silos?
Yes.
Making large amounts of LSD? So I had read about him and then later learned that Dave had a relationship with him. I think that was after I left. That was in the 1990s. But I'm not sure.
Right. And had Dave begun any work using peptide coupling agents in the Lysergimide syntheses, or was that something that came later?
Not that I'm aware of. We were using stuff that was already known. So, yeah, it must have come later.
Right. Wow. I mean, it's such an amazing story. I really appreciate that you're taking the time to tell it to me, because I just love the trajectory of your career.
Well, thank you, Hamilton. And I appreciate you being interested. I've never come across somebody who was interested. It's just, it's a pleasure to talk to you about it. I appreciate you getting in touch with me.
And just to, as a sort of final note, you mentioned the Three Musketeers, and that there were some self-experiments that were occurring. Are there any other experiences with experimental compounds that you might want to share? Because you've had experiences with things that really no one else or very few other people have had the opportunity to try. Anything that you can share that you think might be interesting?
Nothing that I can think of off the top of my head, but I will promise you now that I'll give it some thought. And if something comes up, I will definitely share it with you.
Okay.
You're the man.
Okay. Are there any final things for maybe young people that are getting involved in this space, other lessons about how to work with these compounds and generate new scientific knowledge?
Well, I'm always think back on the notes that Thomas Jefferson wrote about the versus the heart. The head wants this, the heart wants that. And I think it's very important in your career to listen to your head, but follow your heart. And your heart will tell you when you're into something that you feel is right for you and is the path to go. And have a peace in the conversation between your head and your heart, and let that guide you together.
That's great. That's really great. Well, thank you so much for your time. I will send you a copy of this recording. And it's always a pleasure to talk to you.
Thank you, Hamilton. I enjoyed it very much. And I look forward to staying in touch.
Okay. All right. Have a good day.
You too.